Hi there, everyone. Today I will be talking about our missing data do files. So kind of the last piece you really have to do for your group project. So this is what you'll do once you have created your DAG, decided on your final regression model. Then there's one step that you have to do to go back and essentially remake table 1, which we did earlier in assignment 5. For the final version of your poster, the aim here is that we want the people who are in your regression model to match the people who are in table 1. So I'll come back to that and why it's important, but let's walk through this do file. So first, just a reminder, if you need to download the campus data set, campus wellness data set, remember it's linked here under the campus wellness assessment data and materials. So you want to click on this data set link here, save it to your downloads folder or wherever on the computer that you're working on makes the most sense. I already have it there, so I won't save it again. But remember, if you're working through the remote desktop system, you don't want to click on it when it downloads down here because it won't link it to Stata. So just save it there. And then we're going to scroll down to near the bottom of the page under handling missing data. So the only thing in this section is this do file that I'll be covering today. So you can open that up. And as you saw there, there's not a separate assignment on this since we're so close to the end of the semester. You'll just need to do this for your poster, which I'll post another video about how to make your poster soon. Okay, so here's the do file. As usual, I'm just gonna highlight all of it and copy, open up Stata, open a new do file editor, and paste it in there. And I'll go ahead and save this do file as final data restriction, whatever you want to call it is fine. Put it in my downloads folder. And then I can go here and do open my campus wellness assessment. I'm actually going to delete this other one real quick. All right, there we go. So this should match the data set you have. We can always just tab that V1, the first variable in there, and type missing. So you should have 1,557 people in this 2019-2020 data set. Remember that at the start of the semester, we were using a different one that had 1,863 people in it. Now we're using the new data set that has 1,557. And here's the do file over here. So again, the purpose of this dealing with missing data, restricting our data set to only the people who are included in our regression model is so that we are consistently talking about the same students throughout our project. You want to make sure that the people that are represented are the same people across your whole data report. And that's important because there may be differences between people who are included and who are excluded from your study. And if we were going forward to publish and next semester, when I see you in epidemiology, we'll talk more about bias and who gets included and excluded. But for now, I just want you to focus on making sure that your numbers are consistent, the sample size is consistent across all components of the research poster that you're going to put together. So I'm going to keep using the sleep and parent status example that I've used in earlier regression videos. So you might remember that in order to do that, I'm looking at parent status as my exposure, whether or not being a parent, having a child, or being the guardian for a child as a student is associated with sleep. And so I made this inadequate sleep variable where I collapsed the categories for that sleep 7 variable that's in our data set. So I'm just going to run that code again. And then I also just basically recoded the age variable to make a variable called age 21 or up. And so that's what I've been using in my regression model. So I'm going to make those 2 variables. You may or may not need to make variables for your group project. So if you need them, go ahead and make those now, the ones that you need. So the first thing we're going to do is take a look at how many missing responses there are. And there's 2 different ways to do this. You can run a tab like we've done before, as you can see in my screen over here when I did tab age and age 21 up to make sure I had made that variable correctly. I can see there are 1,557 responses. So that means everybody answered the age question. So no one is missing that. But as you build your regression models and you get further and further down in the survey itself, it's more likely that you're going to have people who didn't answer a question. Maybe they ended the survey early. Maybe it's about a topic that they didn't really want to talk about. So if someone is missing any of the variables in a regression model, they will get dropped or excluded from that regression model. So we also want to exclude them from table 1. So one way to start looking at this is to do some tabs. So again, my variables of interest are parent status and sleep. So we can see here, if I do tab parent comma missing, that shows me just the parent variable. It's just a one-way table. So 75 students said that they were parents or guardians, 1,463 said they were not, and there were 19 students who were missing. Remember, a period represents missing in Stata. So right off the bat, we know there's going to be at least 19 students who are excluded from my regression model. We could do the same thing for sleep. If we did tab sleep 7 comma missing, we could see how many students were missing sleep. And we can also do the cross tab here, which is what I've done below this parent and sleep 7 together. So as we saw above, there's 19 students missing parent status. Some of those students answered the sleep question, but 15 of those 19 didn't answer sleep. And in addition, there's another 18 students who didn't answer the sleep question. So we're starting to get a sense of how many students will be missing from our regression model. But doing a bunch of tabs can be confusing because then you have to subtract out the 15 that are included in both this 19 here and the 33 here. So it's easy to make calculation errors. So the way that I prefer to see how many people are going to be missing from my regression model is to use the count command in Stata. And I don't believe we've used this before this semester. So this one's new. And as a reminder, I have on row 53 of my code here, ultimately the model that I'm going to be running is a logistic regression model looking at whether inadequate sleep is different for students who are parents and who are not parents. And I made a DAG, a directed acyclic graph, to see what I should adjust for. And based on that DAG, it said I should adjust for age, sex, and anxiety status. So those are the other 3 variables in my model. Those are the potential confounding variables. So I've added them to the right of my parent variable. So in other words, if a respondent, if a student who answered the survey is missing any one of these 5 variables, they're going to be dropped from this regression model. And so I want to know how many of them there are, and then also to come up with a way to exclude them from my table 1. So step 1 is counting them. And so row 58 of this code is how I can do that. So you can say count if, and then just give Stata a set of equalities, I think is the word I'm looking for, to tell it who do you want to count? What are you asking Stata to count? And so a few things to remember here. First, this is a double equal sign situation. And that's partly because you can say not equal to. So remember that an exclamation point followed by an equal sign means not equal to. But in this case, I've set it up to say count the number of students who are missing parent. So parent equal period means missing the parent variable. Or, remember that vertical bar means or. Missing age, or missing sex, or missing inadequate sleep, or missing anxiety. So basically, count the number of people who are missing any of the things that are in my regression model. So if I run this command, Stata tells me there's 44 students. So I've just written that here. 44 people will be dropped from my regression model. And I could use a calculator to then tell me how many people that would be. Again, there's 1,557 in the whole data set. 44 of them will be missing. So how many are left? I can use Stata as a calculator by using the display command. So if I just type display 1557 minus 44, Stata tells me that there will be 1,513 people in my regression model. So let's run that model and make sure that that's what we get. Here we go. So I've run my logistic regression model Inadequate sleep is the outcome. Parent status is the exposure of interest. And then I'm adjusting for age, sex, and anxiety. And you can see right here at the top, number of observations is 1513. So good news, that matches what we expected based on our counting exercise above. And I'm not going to talk through the interpretation of these because I did that last time in the regression video. But I just wanted to confirm that I was getting 1513. So I did. So we know how many people to expect. I'm going to have 1513 as my final sample size in my report at the end of the semester and in the research poster that I create. So that's half the battle, knowing how many people you have. The second part is then going back and redoing table 1, which again we did in assignment 5, so that we only have those 1513 people in it. And there's broadly 2 different ways to do this. You can either completely exclude those people who are missing any one of those variables from your data set. If you go that route, be sure you save it with a new name so you know it's the restricted data set. It only has the subset of people who are not missing all the variables that you wanted to use in your project. Now, of course, if you accidentally overwrite it, you can always go back to the class website and download it, the whole thing again. But it's good practice to always save a data set with a new name if you make any changes to it. And certainly if we remove people from it, we want to make sure that we name it something so we know that it doesn't include everybody. So if you're going to drop people, you can go one of 2 ways. You can either drop people who are missing things. So that's the option 1 that I have listed here. Row 83 of the code will do that. And you might notice if we scroll back up, it's almost identical to the count if statement. So I basically just copy and pasted my count if row from 58 down here, up here, sorry, to 83 down here, and change the word count to drop. So we can count the number of people who are missing any one of those variables in the model. And here we can drop anyone who's missing any of those variables from the model. So drop if parent is missing, or age is missing, or sex, or inadequate sleep, or anxiety is missing. And when I run that, Stata will give me this output in parentheses. It'll tell me how many observations were deleted when I ran that command. And again, 44 is what we expect. That's what we had calculated up here. So good news, everything is matching. And then this is where you want to make sure that you save the data set. So you can either type it in by hand, or what I usually do is just say file, save as. And then, I usually add something on to the end, like parent sleep restricted or something. So I know it's the data set that I use to make, to do my parent and sleep outcome analysis. Okay, so now I've saved that. And if we want to make sure that there's the 1513 people in here, I can tab that first variable in the data set again, including the missing ones. And I see that there are indeed 1513 respondents in here now. So that's what I expect to happen. The alternate version of this, if you prefer to keep the people you want instead of dropping the people you don't want, that's another way to do it. So row 90 would get you to the same place. So I can demonstrate that. Let me open the original one again. Oops, there we go. Okay, so now I'm back to the 1557 data set. So here, the only difference between rows 83 and 90, other than the drop and keep, is that instead of, before we wanted to drop if they were missing any of those variables, so they all have or signs between them. If you're telling Stata to keep people who have all of the values, you then need to change those or signs to and the missing to not missing. So this is the not equal missing, exclamation point with a equal sign after it. So keep if parent is not equal to missing, and age is not equal to missing, and sex is not equal to missing, and inadequate sleep is not equal to missing, and anxiety is not equal to missing. So if we run this, Oops, sorry, I forgot, since I reopened the data set, it doesn't have those new variables in it. So let me just run back to the top and make those again. Okay. So now if we run our keep statement, it still tells me how many it deleted. It doesn't tell us how many it kept, but it's still the 44. So if I do tab V1 with missing, again, we still get 1,513. So these two options bring you to the same place as long as you've written all the code correctly. Whichever makes more sense to you is fine. I generally do the drop statement just because I typically have counted people first, and so it's a lot easier for me to just copy and paste the count statement and change count to drop. But whatever makes the most sense to you is just fine. So the last option is one in which we actually are not we're not deleting anybody from our data set. So for the purposes of this class project, it's fine to just drop people who we're not including. But there are lots of times in my regular work projects, regular research, where I don't want to completely drop people from the data set because maybe I'm doing an analysis with a subset of people, or I don't want to have to keep like 6 different versions of the data set and worry about whether or not I excluded somebody from it. So I tend to take this approach in practice, which is to, instead of deleting people completely from my data set, I just make an indicator variable to say whether or not I should be including them in a particular analysis. And so that's what this last option does. And to do this, I'm going to have to open the full data set again. I'm not going to resave this. So one last time, let's get back to the full 1,557, which means, again, I'm going to go up and make these variables again. Make sure I have 1557. Well, we can see there from that one that we have all 1557 again. So now let's go back to the end. So again, we're on option 3 now. And this is where I'm going to make a variable to indicate that people should be included rather than deleting them altogether. So my first command here is to just make a new variable. I'm just going to call it include. So make include equal to 1 is what I'm saying here. Generate a variable, name it include, and set the value equal to 1 for everyone. So Stata did that. To confirm, we can do tab include, and you can see right now all 1,557 people have a value of 1 for this new include variable that I just made. And now we're going to replace it with some zeros. So these zeros will be people that should not be included, that will not be included in my logistic regression model, and so people that I don't want to include in my table 1. And again, I'm copying and pasting from my count statement above. So include will be equal to 0, so replace include equals 0 if, and then in parentheses I have to write this long list of conditions. So if parent is missing, or age is missing, or sex is missing, or sleep is missing, or anxiety is missing. So again, when I run this, I should expect to see 44 changes made, right? That's the number of people who are missing at least one of those. And that is indeed what Stata says. But just to make sure, we can do a tab. So we have 1,513 people who are included, 44 who are not, and we still have all 1,557 in our data set. So in order to use this in table 1, remember that table 1 is describing our sample based on exposure. So you have a column for the exposed group. In my case, that would be parents. Column for the unexposed group, students who aren't parents. And then a lot of other characteristics, you know, age, sex, year in school, whether or not they're employed, what their mental health is like, whatever it is that makes sense for your project. So something like this, where we have percentages of the exposed and the unexposed group, students who are parents and students who are not, who are age 21 and older. And so these column percentages are what we'll be putting in table 1. What percent of students who are parents who are age 21 and older, and what percent are under age 21. And we can see I asked for the chi-squared option here, so we can see that there is a difference just like we saw in class earlier this semester, students who are parents tend to be older than students who aren't parents. Logically, that kind of made sense with what we were expecting. And so we see there is a statistically significant difference since our p-value is less than 0.05. And so rather than just running tab age 21 and parent and getting, all maybe 1,557 people, we saw earlier there are 19 people missing parent status, but rather than getting all the people who had values for both of these, I added this if include equals 1. So telling Stata, run this crosstab, but only for the people that I want to include in my final analysis, only those people who are going to show up in my regression model, so that my total consistently equals 1,513. So that was age. I would be going down the line for my table 1. The next variable I have in there is sex. And so same thing, tab sex, parent, if include equals 1, asking for the column percentages and the chi-square test. No difference in sex across these two groups. And so you could just keep going. I just did 2 examples on here, but you'll probably have 5 or 6 or maybe more characteristics that you want to include in table 1. So again, if you dropped people, if you took option 1 or 2 up here, then you could run exactly the code that you ran before, which might look something, in my case, it would just be these 2 rows. I wouldn't need to have an if statement because I've already dropped the people. I've deleted all the people who are missing one of the variables. So I could just run these again. Or you can use the approach where you make a new variable to indicate who should be included. And in that case, you'll just have to remember to include the if include equals 1 statement before you rerun table 1. So hopefully that makes sense. Again, you don't have a separate assignment that's due based on this, but it will need to go in your final poster that you submit at the end of the semester as your final project. So if you have any questions or if you're having trouble getting the correct count of people, getting your numbers to match up, making the restriction, just let me know. And hope you all are doing well. And I will talk to you again soon about how to make those final posters and put together all the last pieces of your project.